So, can you talk us through this one?
So, sine theta equals 1. This one looks a bit different. There are no fractions. Like, every time we used our exact angles, we would always get fractions. From our special triangles, we get half, or 1 over root 3, or root 3 over 2. So this one looks a little bit different in that we need to maybe use a slightly different approach. So here, sine theta equals 1. If we go back to our original, when we used the unit circle, when we first introduced the unit circle, and we had a circle, and it's called the unit circle because it has radius 1. And so let's, Miss Hughes, let's put on our circle there, where the circle crosses the axes, let's just write down what the points are where they cross.
Red.
So that one there, because our circle has a radius of 1, that's going to be the point 0, 1. And then there, it's going to be minus 1, 0, and 0, minus 1, and of course 0, 0. Okay, the other thing we need to remember is when we started with our unit circle, we made a little right-angled triangle inside, and that was theta. And however far across it was x.
Yeah, because it's the x coordinate of this number.
And then, of course, how high up it is, we called y.
Yeah. So we kind of came up with a new definition for sine and cos. So sine of theta, which in this case is the opposite over the hypotenuse, that's just y over 1. So y over 1, which is just y. So if you like, our new definition for sine theta was that it's the y coordinate of this point as it goes around the circle. Yeah?
Yep.
And same for cos. This time is the adjacent over hypotenuse, so x over 1, which is just x. So our new definition of cos is it's the x coordinate of this point, often called P.
So what we can say is that any point on that unit circle has the coordinates either x, y, or we could say it has the coordinates of cos theta, sine theta. So this is what we're going to use to help us work out what sine theta of 1 is. Essentially, we need to find out when is sine theta 1, which one of these points. So we can see if we go around our circle.
Just change colour.
Okay.
Yep.
So we go around our circle and we find where, so sine theta is like the y coordinate. And we can see there, where it crosses the y-axis, the positive y-axis, that the y-coordinate is 1. And remember, we've just said that the y-coordinate is the same as sine theta. Now, what angle does that represent there, Miss Hughes?
I think that's a 90-degree angle.
Yeah, good,
Yeah.
because we've started from the positive x-axis and we move in an anti-clockwise direction. So we've moved 90 degrees.
So, just to recap then, this point here has a y-coordinate of 1, and the y-coordinate represents sine. So, this angle here has a sine of 1, is that right?
Yeah.
So, we've actually found our solution. Theta has to be 90.
Sorry.
Yep.
If we just check our other points that are, if we keep going around the circle, should always check if there are any other points. That one's not, oh, excuse me, that one doesn't have a y-coordinate of 1. That one has a y-coordinate of minus 1, so that's not what we're looking for, and that's 0, 0. So there's only one solution there, between 0 and 360. Okay, so hopefully that's been some help.
Yep.
And in the next podcast we might do some slightly harder ones.
Okay.